Now you'll see the coordination number from the beginning onwards. Coordination number. What is the meaning of coordination number? Generally, we see what is the meaning of coordination number. Very simple. How much the density of a ligand. Otherwise, what happens? How many ligands in the place of density? How many ligands are bonded to metal atom? How many ligands are datively bonded, coordinatively bonded to metal atom? They are called nothing but coordination number, actually, isn't it? Number of electron pairs accepted by the central metal atom or ion is known as coordination number. Here, lone pairs are nothing but here lone pairs, number of electron pairs, nothing but what? If one lone pair is there, density is equal to 1. If two lone pairs are there, density is equal to. If 6 lone pairs are there, density is equal to 6. Nothing but what? How many ligand? One ligand has actually, it may have monodentate, it may have bidentate or tridentate. Okay. So number of lone pairs it can donate. Otherwise, metal complex is there. Now I am taking what cyanide. Now 6 ligands are there actually. 6 ligands are there. Now each one is what? Monodentate only. Each ligand is actually what? Monodentate only. In that case, what happened? The coordination number will be 6. Like that, isn't it? How many lone pairs are accepted by the central metal atom? This is how many lone pairs it is accepted here. 6 lone pairs it is accepted. Therefore, it is called coordination number equal to 6. It is, isn't it? We take an example in this way: platinum hexachloride and nickel tetraamine. The coordination number for the platinum will be 6, right? Yes, because it is a monodentate. So monodentate, for monodentate, what happened? Number of ligands equal to coordination number. It also is monodentate. For monodentate, number of, isn't it, ligands is equal to coordination number. So both platinum, if you observe, the coordination number is 6. For nickel, the coordination number will be 4 actually, isn't it? Next, one more thing also I will explain here. If I take something, this example, I have already took that example, but anyhow, again I will take this one. Cobalt, En taken 2 times. Next I am taking Cl2 like this. If I take like this, now what is the coordination number of this one? Let me see this one. Now, first of all, ethylene diamine. Ethylene diamine is a bidentate ligand. En, bidentate it is. It is a bidentate. Which one? Ethylene diamine is a bidentate ligand. Now, how many actually its density is equal to how much? For bidentate density is equal to 2. So write down here 2 actually. For bidentate ligand, the density is equal to 2. Now, how many there are actually? 2 are there. Multiply this one with 2. So from this we get 4. Now, what about the 2 chlorines? Chlorines are actually what happened? Monodentate. Monodentate. So for monodentate, density is equal to 1 only. But how many there are actually? 2 there. Therefore, we get here 2. Now, total it is 6. Now, coordination number for cobalt will be 6. Coordination number will be 6. For example, if I write like cobalt, then take what happened? Ethylene diamine 1 time. Take Cl2, take Br2 like this. Now, how to make the coordination number? Ethylene diamine, again it is a bidentate. This is also what? Monodentate. Now, what I am writing here for bidentate, density is equal to 2. How many there are? Only 1. Therefore, we are going to get 2 here. Mono density, mono ligand actually. Mono for only density is equal to 1. How many there are? 2. You are going to get 2 here. Monodentate, how many? What is the density? 1. How many there are actually? 2. You are getting here 2. Total how many? 6. The coordination number for this one will be 6 actually. So in this way, we can easily get coordination number actually. Simple lone pair. How many lone pairs accepted by the metal atom is nothing but called coordination number. Next, one more thing we see, coordination sphere. What is the meaning of coordination sphere? So what happened? The central, whenever the ligands are attached to the central atom, which are present in the square brackets, they are called coordination sphere. For example, you take this example. You take this example. Cobalt, NH3 taken what? 6 times. Next I am taking what here? Cl3 I am taking. Now what is coordination sphere? Whatever we have taken inside the brackets here, inside the square brackets, this is called what? Coordination sphere. Now this is called counter ion. It's a counter ion. This will have minus plus 3 charge actually. Counter ion it is. Okay. The ionizable groups are written outside of the sphere is called counter. This is the counter. These are ionizable. For example, if I ionize this one, if I dissolve in the water, what happens here? It will dissociate into like this. It will dissociate into like this. Plus 3 moles of Cl. This is called counter ion, and whatever inside the square bracket, that is called what? Coordination sphere, we can call this one. Next, these are the important terms we are using in coordination compounds. Next, coordination polyhedra. That spatial arrangement, in space, how they are arranged. When the ligand is attached to metal atom, when the ligand is bonded to metal atom, what the shape we are going to, what shape we are going to get? When these ligands are bonded to central metal atom, what shape we are going to get? That is called what? Coordination polyhedra. Most of the cases, what shapes we get? Octahedral, square planar, and tetrahedral. These are the 3 shapes generally we get actually. You will take one example. So whenever if you have 6 ligands, definitely it will be octahedral shape. Whenever if you observe 6 ligands, the shape will be octahedral. If you have got 4 ligands, it may be tetrahedral or it may be what? Square planar also. Depend upon the structure. Okay. So when you get 4 coordination number, you may get what? Square planar, or you may get what happen? Isn't it? Tetrahedral also. So how we got tetrahedral, we'll discuss in this one. In BBT theory, it will explain everything. I will explain because it will have sp3 hybridization. Therefore, they have based upon hybridization, we can say sp3 hybridization will have tetrahedral, and dsp2 or sp2 do D always will have square planar. But what I mean to say, when you have 6 coordination number, you will have octahedral. When you have coordination number equal to 4, you will get tetrahedral shape. For example, you observe here what happened: cobalt, ammonia. Here also what happened? Ammonia. I have taken 6 ligands now. Now definitely I should get this structure here, octahedral. Let me see octahedral is getting or not. Let me see. Definitely what happened? You will get octahedral structures. In this way, you are getting what? Octahedral. This is a spatial arrangement of this structure actually. When I take 4, what happened? What we get? Nickel I have taken. Nickel I have taken one CO here, other CO what happened here I have taken, and CO I have taken here, and one more CO I have taken. Now they are bonded like this. Now this will definitely have what? A tetrahedral shape like this. A tetrahedral shape. Square planar, how we get? When you have like this, platinum, Cl. Now we get a square planar like this. So very simple. Polyhedron means the spatial arrangement of the ligands when they are directly bonded to what happened? Metal ionities. Now this is very, very important. Homoleptic complex and heteroleptic complex. Very simple to understand and very important also. Homoleptic and heteroleptic. Homo means what? Same. Hetero means what happened? Different actually. Now, what is the definition? If complex compound bonded to only one kind of donor atoms, all are what? Same type of donor atoms, then they are called homoleptic. If they are different, they are called heteroleptic. You take one example. You see, the ligands are same only, homoleptic. Okay? The ligands are very same. You say take platinum, just now you are taking PtCl4. This type of ligand, it is definitely what happened? Homoleptic. Because ligands are what? Same. Isn't it? So complex in which metal bonded to more than one kind of donor groups. That means different type of ligands it is donated, having bonded here. In that case, they are called heterolytic. See, you see, one is amine, other is what? Chlorine. 2 different or more than 2 different types of ligands. They comes under what here? Heteroleptic complex compound. Different type of ligands present. They are called heteroleptic ligands actually. Complex ion. What is called complex ion? The meaning of complex ion. So anything which is having what? Electrically charged radicals, which is formed by the combination of simple cation with one more neutral molecules or simple anions, some case of positive. So very simple I am saying here. This is the complex ion. This is the complex ion. Why you are calling complex ion? I will show this one. Let me see this one. Now when it dissociates, what happened? It will dissociate to 4K plus what happened? FeCN taken what here? 6 steps. Now, how many positive charges are there here? 4 positive charges are there. Therefore, put here 4 negative charge. Now, this is a charged complex compound. This is a charged complex ion. This is the complex ion. in which the ligands are bonded to what? Metal ion. Sometimes we get positive also like this. If I take something like this, you will get positive also like this. Cobalt, NH3, taken time 6 times, chloride. Now, when you dissociate this one here, you will get like this. CO, NH3, taken what? 6 times and plus 3Cl minus. Now, how many negative charges are there here? 3 negative charges. Now, how I have to put here? 3 positive charges. If you have 3 negative charges, put 3 positive charges. If you have 4 positive charges, put here 4 negative. Because counter ion we have to make. Now, this one is called what? Complex ion. Complex ion. A complex ion is having which charge here? Positive. Cation. A complex compound is having which charge here? Negative. And that means we have anion complex, cation complex. That depend upon the counter ion. If counter ion is what? Positive, we got anion complex compound, isn't it? If counter ion is what? Anion, I got the cation complex compound. Sometimes, isn't it? We don't have any charge. Ion, chargeless complex compound will be there. You see, nickel, CO taken 4 times. This is not having any charge. No charge. So this is not called complex. This is a simple complex compound. It's a complex compound only we can call this. Now this one will take in terms of diagrams. Take in terms of diagram. What happening inside? This is the actually this one I have taken K4FeCN6. Now dissociating into 4K plus and FeCN taken 6 times. Now this is a simple ion. This one is a simple ion, right? This one will be what? Complex ion. This one will be a complex ion. Anion complex ion. Complex ion, right? In terms of diagram, you can also represent like this. Okay, this is the complex compound. This is what? Complex compound. Complex compound is having counter ions. Simple ion and complex ion. Coordination number for this one. How do you find the coordination number for this one? See, ammonia. 2 ligands are there. Ammonia is monodentate. It is a monodentate. Now there are 2 are there. Monodentate means what? Only 1. Its denticity is equal to 1. How many are there? 2 are there. Now that is equal to 2. Now the coordination number will be for this one 2 here. Don't take counter ions here. So most of the students they do mistakes here. So how many ions are there? They take no. Whichever inside the complex, they called as ligands. Outside they are nothing but counter ions. They can't take that. Now water monodentate. Ammonia again monodentate here. Now monodentate, how many there? Only 1 here is equal to 1. Monodentate how many here? 5 here. Equal to 5. Total is equal to 6. Coordination number will be 6 actually in this way. Don't consider this one because it's counter ion. We don't consider this one. Only which are present in the inside the complex compound because they don't undergo dissociation. If you do what happen actually, why you are not considering this one? If you do dissociation, what happens here? Cobalt, H2O, NH3 taken what? 5 times. Plus we get 3 moles of I minus. This will be dissociated. This will be completely outside of from the complex compound. So this will be remained actually. So now this you are calling as a complex. Now this is about the coordination number and coordinations. Polyhedra.